We are cruising. We're up to 1-3 already. Next thing you know, you'll be in second try. Let's go. So, 1-3, pre-lesson. SOHCAHTOA. Don't know if you were introduced to this in good old Algebra 2 or not. Probably. But here we go. What the heck is this? Well, this is an introduction to a little trigonometry. Not much, just a little taste. So the first thing we're going to talk about is this thing called sine, cosine, and tangent. Okay, we need to get very familiar with these. A lot of trigonometry is packed into pre-calc / calc. So with that in mind, what does this stand for? Well, sine is opposite over the hypotenuse. I'm going to abbreviate. Cosine is the adjacent side over the hypotenuse. Now notice when I say hypotenuse, you can't have a triangle like this, and this is not the hypotenuse. So don't think, oh, it's the longest side. It has to be a right triangle. That's the only way you can use trig. So keep that in mind. You can't use these functions on this. So with that in mind, tangent is opposite, I'm going to abbreviate, over the adjacent, I'm going to abbreviate. Now if you look at your calculator, they abbreviate sine to sin, they abbreviate cosine to cos, they abbreviate tangent to tan. So get used to that. So how do we use this? Like I said, it only works for right triangles. So there's my right angle. Typically, the right angles assign the letter C because, remember good old Pythagorean theorem? We're going to talk about that in a little bit. A squared plus b squared equals what? C squared. So that's why the hypotenuse, the angle, is called C, is opposite. Opposite that is the little c. I'll talk more about that in a minute. I'm going to put an A here, which means little a is right here. I'm going to put angle B here, which means little b is there. Always. Little b is opposite big B. Little a is opposite big A. Little c is opposite big C. Now with that in mind, what they're going to do, they have all these symbols. Theta, alpha, I'm not good at making beta, but beta, Greek symbols representing angles. This book tends to like alpha. So they're going to put alpha somewhere. And if they put it there, that means A is considered the side opposite alpha. This side doesn't have anything to do with this. It's just the hypotenuse. It just is. Which leaves us, if we've got these things, opposite, adjacent, and hypotenuse, we've already used this, we've already used this, there's only one left. That means this has to be the side adjacent. So that's my strategy for you. Find the opposite side, find the hypotenuse, the remaining side will always be the adjacent side. There's more to it, but I'm going to leave it there. So with that in mind, if I said, okay, find sine of alpha. Well, remember, it's so that's opposite over the hypotenuse. Now, we don't have any numbers here, so we're going to use the letters. So in this case, the opposite side would be A, hypotenuse would be C. What about if I ask you to find cosine of alpha? Well, that is adjacent over hypotenuse, adjacent over the hypotenuse. So we're going to build a fraction. Here's my adjacent side, it's B. My hypotenuse is C. Now what in the world would tangent be? Well, that's opposite over adjacent. That's why it's important to know your SOHCAHTOA, opposite over adjacent. So my opposite side of my reference angle is A. My adjacent side of my reference angle is B. And there you have it. One thing, if they don't have this in there, they're going to have to clarify it by saying A, and A. Sometimes they won't put that little Greek symbol in there. Sometimes they will. Don't panic. It all means the same thing. Let me pause this a second. Okay, here's a real sample problem forcing us to use trig. First of all, we gotta have, if we're gonna use a hypotenuse, we gotta have a 90-degree angle. There it is. So now we're free to use SOH, COT, TOA. But now we have sides. So this is a right triangle. So if you remember your families, 3, 4, 5, 5, 12, 13, 8, 15, 17. All I'm saying is there is no 6 blank 11. So if that's the case, you got to use your good friend, the Pythagorean theorem. And you got to know that this hypotenuse is always C. A and B doesn't really matter. So I'm going to say that this is A. So it's A squared plus, whoa, I might have confused U. Because what I explained was this, if this is angle A, this is side A. If this is angle B, this must be side B. So I don't want to throw you. So A squared is what I don't know. B squared is 6 squared. C squared would be 11 squared. So quick math, I'm going to go A squared, 121 minus this, because I got to bring that over, 36. I made these numbers up. Uh-oh, give me a second. Normally I can do a lot of math in my head, but that one I just wasn't trusting myself, so I did my math over here, is 85. So now I got to take the square root of both sides, and then I go, aha, this is the square root of 85. Now I'm ready to find sine, cosine, tangent. Now notice, this is my reference angle, reference angle, reference angle, so we got to focus on this angle. That would make this my opposite side. We know this is our hypotenuse, and by process of elimination, this has to be my adjacent side. So now I can build these fractions. Sine is opposite over hypotenuse. So what's my opposite side? Square root of 85. What's my hypotenuse? 11. Weird looking answer. There it is. Cosine. Cosine is adjacent over hypotenuse, so that's just 6/11. Reduce these if you can. Tangent of angle A is opposite over adjacent, so we get the square root of 85 all over 6. Okay, here's how we use trig and Pythagorean theorem if we need it. Quick reminder of how to factor things. So this is an expression, this is a different problem, but we got to factor this. So what do you got to do? You got to think, okay, I'm going to take out as much as I can. So really, back in the day, you were talking about greatest common factor. That's what you're trying to find, the greatest common factor. So in other words, take out as much as you can. Well, this has 2 x's, this has 1. That's all I can take out. So if I took 1 x out of this, I'd be left with 1. If I took the x out of that, I'd be left with 9. Simple stuff. But then how do I check my answer? Distribute it and see if I get this back. Ding, 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 ding. Let's go to this one. There's a minus in there, so I got a 12 and a 48. Largest number that'll go into both those, 12. I got 2 x's, 1 x. Most I can take out of both of them is 1. So I'd be left with x minus 4. Distribute it to make sure you did it right. Pretty simple. All right, I like where this is headed. Just kind of putting the building blocks in place in Unit 1. You got to have these. So now we're talking about breaking down square roots or cubic roots, but radicals. This is my go-to sample problem. Money. Watch this. What's the square root of 4? 2. What's the square root of 25? 5. What's the square root of 100? 10. So, first of all, is this true? Yes. So, what does this tell us? Well, it tells us what's 4 times 25? Well, that's 100. So if I look at this and I think left to right rules, it's okay to multiply, square roots. Okay? It just works. Wait a minute though. What if I read this right to left, which you guys aren't used to? But math is a language. You can read it left to right, right to left. We English speakers, we're just constantly thinking left to right. Math kind of goes above and beyond that. So what's the rule? The rule is I can take any square root and I can break it up into the product of 2 factors. So that's the rule. Now, we're going to use this example in a few, but I want to talk about something I like to use, and it's this oil-water concept. So let's do this. Square root of 100. What's the square root of 100? 10. So this is 2 times 10, which is 20. Now, why am I showing you this? Watch, watch, watch. I call this oil. I call this water. If you put oil and water together in a bucket, you try to mix it, they don't mix. So mathematically, I want to prove that to you because we know that this equals 20. Well, let's go in an experiment and try to mix them. You get the square root of 200. Is the square root of 200 20? No. We know the square root of 400 is 20, but that's not what we get if we multiply oil and water. See, that is incorrect mathematically. You cannot multiply oil and water. You can't throw a whole number into the radicand and do math correctly. It just doesn't work. Okay, let's do a couple sample problems. So here we go. These are your basic problems. But remember, this is my oil, this is my water, so I shouldn't even think about making this the square root of 36. Doesn't work. Square root of 36 is 6. You know that that just can't be true here. So what are we supposed to do? Well, this kind of comes along for the ride. This, we go to our list of perfect square roots. We try to find the largest perfect square root that goes into 12. We break it up into the product of 2. What's the largest perfect square root that goes into 12? 4. And 4 times what is 12? 3. Now watch this. That turns into 3. What's the square root of 4? 2. Square root of 3. Now we got oil and oil. Can oil and oil mix? Yes. So there's my final answer. You can't go any farther. What about this? Well, this could take us back to a previous lesson. If you wanted to, you could go, aha, I slide my radicand over. There's my power. That little invisible index goes there, and I get b to the first. Or you could just say, you know what? The square root of b squared is just like the square root of 7 squared, which is just 7. So you could just go right from here to here. Now, that's all built up for this. Let's take a look at it. Square root of 28. Again, 4 times 7. Now, whoa. What is this? It's the largest perfect square root of 28. What are we going to do with this? We're going to break that up into the product of 2 also. Now remember, there's an invisible 2 there. So here's how your brain needs to function. What's the first number less than 5 that 2 goes into? That would be 4. So x to the 4th is kind of like our 4 for our 28. How many would be left? 1. Now we break these up. 2 square root of 7. Now remember, 4 divided by 2, because that's what we do, is x squared times the square root of x. Oil and oil, bring those together. Water and water, bring those together. Now as a side note, if I looked at the square root of x to the 5th, you could actually make an argument, take the power, put it over the index. This is also true. But it's not what they want you to do on these problems. This is what they want you to do, not this, even though that's correct. Last part of our pre-lesson here. So now all of a sudden they're going to talk about, this is called transformations of parent functions. So I'm going to take you by the hand, metaphorically. Here's our parent function. You guys have seen this before. You should know what it looks like, but I know we haven't talked about it much. So let's go ahead and plug some numbers in. What's the absolute value of negative 3? We put that in there. 3. This would be 2, 1, 0, 1, 2, 3. If we plotted all those points, it would look something like, oops, I was supposed to do that in red. It would look something like this. Now, what is this purple one all about? Well, all it's doing is adding 1 to whatever we got to our original parent function. So this would be a 4, 3, 2, 1, and whoops, excuse me, 4, 3, 2, 1, back to 2. Anyway, what does this do? Well, if I actually plug them all in, negative 3, negative 2, negative 1, 0, 1, 2, 3, you get 3 plus 1 is 4. That'd be 2 plus 1 is 3. 1 plus 1 is 2. You can kind of see the pattern. And then we're back to this. 2